Hello everybody. Yes. Hello everybody in Zoom. Thanks very much for coming today. I'm very grateful to Rachel, who's part of the quality improvement team. She's one of the facilitators and does a lot of work across lots of parts of the organisation in quality improvement. So she's going to tell us today about data for quality improvement. So this is probably one of the most interesting sessions on the curriculum because, well, if you're like me, who likes data and nerdy stuff, but this is where, you know, you can use data to help you form conversations about quality improvement. So it really backs you up and makes you talk from a position of knowledge rather than just from a position of opinion. So without further ado, over to Rachel. Thank you. Oh, sorry, one little thing is this is being recorded just for the benefit of people who are not here. So if you don't want to be featured in the recording, then please mute and turn off your video, and obviously just stay quiet at the back of the room if you want to stay out of the show. Okay?
Great, thank you. Those slides. Perfect. So as James said, the session is about additional QI tools that we've, data tools that we have as part of our toolbox really in QI. So the objectives of what we're going to do today is we're going to have a look at run charts and look at the different components of the run charts, see if we can start to become familiar with the different parts that make up the run chart. We're going to have a look at some of the information the run chart can give us, and in particular we can start to look at some, it's called common cause variation and special cause variation, so we'll start to have a look at that. Then we've got another few tools that we can have a wee look at, and include that is the Shewhart chart, some and then what that can tell us, and then we've just got a few other charts we can look at, so histograms, Pareto charts, and scatter plots. Thank you. We've just started, so we haven't missed too much. So what we're going to start with here is how to display data on a run chart, what we can learn from those run charts and control charts, and all the other stuff. So that's the outline of where we're going. So a run chart, that's sort of a really basic piece of information. You'll see run charts in lots of the QI work that you do. They're a really useful resource for giving us information about what's going on with the process. So essentially what a run chart is a chart that displays information over a time period. So this is an example of a run chart. Key parts of this is the axes. So on the y-axis is what we're measuring. X-axis is the time span, so that can be days or months or years if you're really patient. And then the data points, which are plotted here, obviously in blue. Along the middle is the centre point, or in this case, it's the median, and that gives lots of information about how data is responding in relation to that median. Why we might use a run chart is they're really easy to construct. So draw one up. You can use Flash software, you can use Excel, you can use lots of things, or you can just use a piece of paper and you can plot it yourself. So they're really easy to do, really easy to interpret. You just look at it, and by the end of this, hopefully you can look at it and there'll be a story that you can learn from just looking at the data. So you don't need a big knowledge of statistics nor statics, apparently. And you can start that data collection right at the start of any project. So it's a really handy resource. Oh, I've stopped working.
Okay,
Thank you. So, one of the real advantages of a run chart is the story it starts to tell us about our data. And so some of the things, the characteristics of data that we will have available to us is there's always variation. Variation is just a natural part of what happens with data. And any process we have. So what we want to know about is whether any variation we're seeing in a process is expected or whether it's for some unknown event. And so that might be a change in quality. So data variation that we'd expect just in the course of everyday events is common cause variation. And that's things that are just inherent to the process, day-to-day variation, things that we can predict that might happen along the way. It's not due to regular, natural, ordinary causes. It affects all outcomes of the process. And it results in an overall stable process because it's expected. So just a small amount of variation is expected. And it's also known as random or unassignable variation. On the other hand is special cause variation. And so that's not inherent to the process design. So it's something outside of the usual day-to-day processes, which is due to irregular or unnatural causes. It will affect some, but not necessarily all parts of the process. And it results in an unstable process. It's not predictable. So once we start getting these special cause variations, it's really difficult to predict what might happen next. And it's also known as non-random or assignable variation. So I thought we might just take a moment here and you could maybe just talk in you 2, 3 and 3. We'll just have a quick chat and see if we can come up with some ideas of things that might cause variation that would be common cause variation and some examples of things that might be special cause variation. So we just take a minute or two to think about what that might be.
There is common cause variation. It's really good, especially with variation. It's not to say what it is. It's called a massive specific. And that's really something may have happened in that specialty. It's just
what would be no? So what would be an example of common cause variation in the process? Yeah. Yeah.
So we've got some ideas that we've come up with of either common cause or special cause.
So we're talking about common cause being very different today. So we're talking about companies generally pegs within their day that are common based on people calling. So like our IRD peaks through lunchtime, was our has a peak early in the morning. ACC we have a peak sort of later in the day. It's just because of how questions relate to their individual requirements associated with that certain service.
Good, good. So what about any special cause variation that would apply to this call centre?
It's the classic obvious one of COVID outbreaks.
Yeah, it's like the answer for everyone.
Yeah. It's pandemics.
Yeah. Good. Okay, what did you guys come up with?
Well, we came up with special cause would be COVID and how things change all the time. Might be doing this, following this procedure one day, next day might be following something else. Whereas if you're looking kind of similar things, you might look, okay, well, maybe every winter you have flu season, so it will be a common cause variation.
Mm.
You're kind of planning a little bit for it.
Yeah.
Whereas pandemic, you know, we do now, but
Yeah. Good.
So I use the example, because obviously sometimes the graphs come through to me first for any safety first input and common cause variation related to consumer feedback and the complaints that we're receiving, whether that's within normal variation or whether a special cause variation might indicate a specific set of events in a certain area. For instance, long waits in orthopedics sometimes cause that special variation because the complaints there'll be a certain time where we're not doing very well. You know, the long waits are, I think, to lots of people that cause a spike.
Good. Okay, great. So yeah, those are all really good ideas, and that I think you've captured that really well. And so the run charts, they can actually give us the tools to help us understand whether something is common cause or special cause. Oh, next one, please. And so there's a few rules that we can apply to our run chart, and that can give us some indication about the variation that we might come across. So the first rule is a shift, and that's when we plot our data and it's 6 or more consecutive points above or below the median. So there's quite a nice example up there. The trend is 5 or more consecutive points, all increasing or decreasing. Next one, please. Rule 3 is too many or too few runs. And so if we just flip to the next slide, I'll just give a wee explanation of runs. So a run is the number of points about consecutive points above or below a line at any time. So for instance, so if there's 1 point under the line, that's a run, and then another one above is another run. So it's consecutive, a run is a set of consecutive points that are above or below the median, not counting ones that fall on the median. So how many runs are there on this chart? How many?
Is it 35? Not counting ones that are on the median.
So it consists of 1 or more consecutive, so a run is consecutive data points on the same side of the median.
Oh, on the same.
So not including anything that's on the median.
3?
Yeah, I would have done 2 too. But I don't know.
Okay, so on this one, there's actually 5. Do you want to flip to the next slide? Next slide.
Yeah.
Oh,
So there we go. So these are individual points, consecutive points on one side of the mean. So 1, 2, 3, 4, and then this whole lot here is one run because they're consecutive points all on one side of the mean. So run. So next slide. There's also some mathematical formula we can use. So depending on the number of points we have, we can work out what's an appropriate number of runs that we should have for any set of data. It's kind of complicated, but I think we can say by looking at that for any set of data that was as long as it's about 20, it'd be pretty unlikely that for typical distribution, you'd expect to have just 2 runs, which that data has. And then rule number 4 is the astronomical data point. And that's one data point like this one here that just really stands out. And there's something really way out really that's happened there. So something unusual's happened to the process, and it's a really unusual event. Okay, so on the slide here, so we'll just have a wee look at this, and just out of the 4 rules that we've just looked at, so that was the shift, the trend, the number of runs, and the astronomical data point. What can we see on here?
Astronomical data point.
Anything else? So, pardon?
6, right?
Anything else? So can we see any shifts or trends there? So what was the definition for a trend?
Increasing or decreasing.
So if we click onto the next, so have we got any trends there? Yeah. 1, 2, 3, 4, 5. 5 or more consecutive points going in one direction. So there we go. There's the astronomical point that sort of is really it's an easy one. And then the trend. You were right. If this, these last 4 points, if we'd maybe had more data, it may have become a trend, but we'd need at least 1 more point in the same direction before we can make that call. So other helpful tools that we can use are the Shewhart Chart, Histogram, Pareto Chart, and scatter plot. So we'll just go on to the next one. So Shewhart Chart. So the Shewhart Chart, that's also known as a SPC chart or statistical process chart. So it's very similar in some ways to a run chart. It's like a run chart, but a few more things on it, in particular the upper and lower control limits. There's statistical limits that are added, and they're plus or minus 3 standard deviations. So they just add a different layer of statistical control to it. Sort of, because it does add that extra level of control, so you can see if you're outside the control limits. The disadvantages of this is it requires statistical software to use the chart, so and it's not maybe as accessible for everyone to use. So the next one is a histogram. So histogram's basically a bar chart, which I think we're probably all familiar with. Used those for years, I think, probably starting in high school. And histogram is really useful for showing distribution of a data set. In particular, sort of things that we can look at when we look at the distribution is we're looking at the shape of the distribution, the spread of the data. Is it high peak or is it low peak? And the shape, the spread in the centre. So that's what we're looking for. So this here is obviously lots of data at the beginning, and then it sort of tails out, but there's other data we might look at and we would see bell-shaped distribution, or, you know, there's lots of distributions we could see. So that's just a really useful thing for looking at our data.
I'd say that's bimodal. So the 1 to 2 day one might be the inpatients, and then the others on the other side is actually outpatients. So you get 2 targets, 2 different populations, and you've got bimodal distribution.
That's really interesting. And that's, yeah, and that's a good point that James is making, is that the data can reveal lots of things about what might be going on with the process and give us lots of information. We go into the Pareto chart. The Pareto chart is based on, it's a really interesting chart, I think. It's kind of one of my favourites, so I'm a wee bit biased, but it's based on the Pareto principle, which is the 80-20 principle, and that's pretty much the law of the vital few in the trivial many. And so that means that generally there's a few things that are changing the process, and they're the biggest proportion of things. And then there'll be a whole lot of trivial things that are less important. So if we want to focus on the 80% that are affecting the most things, if we concentrate on 80%, we're most likely to get the biggest change. So in this graph, for instance, those first 3 items, they all become their 80%, and all these other wee things are just sort of the remaining 20%. So to get the biggest bang for our buck, if we're going to do a change process, it'd be good to concentrate on those first 3 that are under the 80%. And then scatter plot, it's fairly self-explanatory, but it just shows the relationship between the 2 data sets. I think the key thing here is that as staff work less hours, they feel happier about it, they're more satisfied. The more hours they work, the more dissatisfied they're getting. And next one. Oh, we're going to, hopefully this will,
Yep, it should work.
this should work. It's just a short video about using these tools.
It's just if people on the Zoom can't hear the audio, just give it a shout and I'll see if I can make it work, but I think it'll work now. Can you hear Maria?
No.
Okay, let me sort it out, hang on. There's a funny setting you have to do. There we go. that better? No, oh, no, sorry. Okay, usually that was fine. Share sound. Let's try that. Keep that now? Yes.
If we're going to try to do system thinking, so appreciation of systems is a fundamental part of the science of improvement. And if I'm helping somebody, and so I need to appreciate the system, well, I have to be able to see that system. I remember when I would do work in auto organizations, they actually designed the big production plants there where you could go up to the very top of it and stand in the scaffolding and actually see the system working and how it's flowing and so forth to do that. In healthcare, it's sometimes very difficult to see the system. You know, hey, the system's a problem here. Well, where's the system? I can't see it. Where do we look at it? So what tools do we have that? So tools like flow charting, process mapping, and so forth that allows us to see the system is a pretty important tool. On the other hand, as I see people, if I tell people you need to have flow chart, they get bogged down in that tool. So doing flow charting, drawing systems maps is not improvement. That allows us to see the system to make that happen. So I'm always careful about ever overemphasizing any tool there to do that. Probably if there's one that I wouldn't do without on any improvement work or projects is a time series chart, a run chart, Shewhart control chart over time there. I always want to see that improvement's temporal. We have a past, we have the current, and we have the future. And I want a picture that helps everybody see that the same way. And so a run chart, a Shewhart chart. I'll always have that on improvement project.
So just some questions for discussion now, really. So, do you want to pop the next slide up, please? So this first question, if we just have a wee think about that for a moment, when embarking on a healthcare improvement, why is it so important to see and appreciate the full complexity of a system? Take a moment and you can talk amongst yourselves if you like. And we'll see what your ideas are.
So you mean so you can measure the changes?
What I mean is how you can say what the facts that you usually when you try to do improvements, and if you don't look at the whole system, that improvement usually has an effect somewhere else, and it can be a detrimental effect. Yeah.
Also, you might think change in the right way.
Yeah.
Is that because we're not taking a wide ranging view changes that we make?
Okay, so have we got some ideas to share? You guys? Any thoughts?
Because you can know, say, your little part of it, if you don't appreciate the whole system of what's going on around, and you cannot sort of see where the driving forces to go, so it's important to have the whole picture as much as you can before, trying to do changes and stuff, because you can just be focused on your little area, but
people who are around you might be doing something for another reason, and if you don't appreciate that, then you may miss an opportunity for change.
Guys?
So we talked about something fairly similar about if you're implementing improvement cycle, that to know the full complexity of the system would allow you to appreciate the unintended consequences of the improvement cycle. So yeah, we sort of discussed that, and also if you have any run charts where you see trends that fall outside medians, the factors that are causing that may be as a result of the complexity of the system, and some of those things that you might help try to improve may be something that you can't actually improve.
Good. And good to hear you coming back to the improvement cycle too. So that's a really good thing to remember, that all of this comes back and feeds into the improvement cycle. So,
We said the ripple effect.
pardon?
The ripple effect,
Oh,
as in, if you don't, often some improvement work has a ripple somewhere else that you may not have considered, and it can change it in an adverse way when that wasn't what you intended, if you don't try and anticipate as much of the full system as possible.
good. Has anyone online got any comments to add? No, that's right. Okay, so that next question then. So how have you used visual tools such as run charts or flow charts to help with your improvement? And if you haven't used these, how do you think they could have helped you? So do you just want a moment again to think about that? Has anyone instantly got a situation where they've used them and they want to share?
So when doing any form of project management, you obviously management by exception if you're mapping things out, and having the run chart sort of going alongside that, when you have those data points which are kind of way out of the way, can kind of give you a bit of a prompt to go and sort of manage the project, and something falling kind of way outside the normal perimeters.
Yep. Good. Anyone else use some of these tools?
I guess if you're looking at like peak times, you might use that for staffing. So you might go, okay, like go along and all of a sudden peaks upwards. So you go, okay, well, where do we need to have more staff on shift? You know, you might not have even thought of it until you looked at the data.
Yeah.
Oh, we used to do a lot of flow charting around current processes to identify bottlenecks and areas for improvement. That was always really good to show everybody the different roles and steps involved in processes.
And did you often find that once it was mapped out that people were surprised? Did they learn, they had expectations around how they thought the process was versus what it was?
Yeah,
Yeah.
definitely.
So I think that's something that all sorts of data from quality improvement can reveal, is we have expectations about how we think it might be, and when we start to look at the data and the flowcharts and the other tools, that they actually often reveal something that we weren't aware of. So they're really good things to get into the habit of having a look at. But then the flip side of that is the video we just watched. They talked about getting bogged down by overusing improvement tools. And any thoughts about why he warned us about that?
You could spend too much time looking at the data instead of actually actioning it. So you want the data to fit almost what you want to say. So you're always looking at that instead of actually putting into practice improvement.
Yeah.
Quite often when developing process maps, you end up identifying some pivotal decision-making points, and then trying to map out human behaviour, but if anything falls outside of some of those processes, people can kind of lose their way and end up spending too much time on going, well, what decision should I make? Whereas instinctively they could make the most appropriate decision, especially if it's a time-restricted decision.
And I've also experience working with groups, particularly with process maps. I think people can get really bogged down in the detail. And I think they have every single little thing written down. And just spend doing the process map for the next year, and you still wouldn't get it all done.
Touching on that, bogged down in the data and making the data perfect. Does anybody come across presenting data and the person you're presenting to the group says, I don't believe that data, or that's not right?
Well, when we present data to, sorry James, doctors, generally, they don't often like our data because they're used to, quality gold standard research data, and that's not what we do on quality improvement, is it?
So how do you get around that?
We talk about small sample sizes, and that we're not doing, research trial standard stuff, but we just want to get an idea of the picture. We're trying to give a picture of what's happening and what's, so it doesn't have to be totally encompassing. Yeah. Sometimes I still don't care.
Sometimes it's also you showing that this is a snapshot, this isn't a year's worth of data, this is a month's worth of data, which is what we've got over this specific period, and making them understand that it's not always the full picture, it's a picture of what we got at that time.
Yeah.
And those pictures are always changing as well.
I mean, I generally have this conversation on a daily basis, and quite often talking with doctors about data, and I quite often use, my favourite saying is you should use data like a drunken man uses a light post. You should use it for support and other illumination, so generally, it's just kind of supporting stuff that we already know is kind of going on and going in certain direction. So.
Yeah. But sometimes, as you say, the data says something else. A good example of that would be in the UK, the ED 4-hour wait. And that's something that's been researched for many years as to why it's going on. Why are we struggling with the 4-hour wait? And the answers kind of consistently come back is that there's problems with discharges in the hospital. But it's actually the back door, not the front door, that's a problem. But that doesn't seem to get the resource from any of those projects. So although the data's saying that's the most important problem, all the resource gets put into the ED and the processes within ED and making things much more efficient and things like that. Of course, they still struggle with their 4-hour wait because they can't get people out of the hospital. Another little tip that if it's possible, so if you're running your project and you're able to sort of think about persuading the end user right at the beginning, what you could do is actually involve them in the data collection so that they own the data. So then when the data comes out at the other end, all analysed, they can only point the finger at themselves if the data is wrong. And so that goes a long way to persuading you that what you're looking at is right. It's not always feasible, but it's a useful trick if possible.
I've definitely had that experience. I spent days in a department measuring some data, collecting it, heaps of it, putting it all together, presented it to them, and they were like, this is rubbish. This can't be the case, not possible. And so they redid it all. And then they were like, oh, it is. But it was just the fact they didn't have they didn't know the process, which we didn't expect them to. That's why we were looking at it. But they were really surprised what the data showed. So had they been involved in the first place, they would have, I assume they thought I was from outside the department, so I didn't know what I was doing and I didn't have an understanding. So if they were in there in the first place, we would have had that understanding and they would have been on board from the beginning. But that was a really good exercise for all of us, really, to see that it was worthwhile to have them involved from the start.
Sometimes they can also be isolated in what part of the process they do, so they think their part of the process works really well, but they don't see the outputs that they give to someone else, which is where the process is actually failing, or where it's not effective as well. So I think, oh, that's really crazy because it goes so smoothly here, but you're highlighting that the effectiveness is in different areas of the process.
And that's a really good example also why it's really good to get lots of people involved that are involved in all parts of the process. So that's the main part of this presentation. I guess, is there anything that anyone would like to sort of, it's brought up any issues or any experiences where you think you could use some of these resources, take them away and start to use them in your day-to-day jobs? So a situation you might be able to use a run chart and collect some data and examine it a bit deeper.
I like the example I saw at Unipart in Oxford, which is a large distribution factory for car parts all across the globe. They employ about 10,000 people. It's a big organisation, a lot of money, budget and stuff like that. And on their shop floor they have these little comm cells. So in the warehouse where the actual forklift trucks move things around, they have what they call a comm cell, which is basically just a board with some key metrics on there and things about staffing and all that stuff. And their run charts are paper and pencil. So that they don't have these digital boards and stuff because it's not accessible to all their staff, and they want all their staff to use this, and all their staff actually have time, dedicated time in their job roles for quality improvement. So when it comes to the cleaner on the floor using run charts, they want them to be able to do it as well. So they literally have a bit of paper on a notice board with some graph paper on it, and people are putting points on it and drawing lines between it as it goes along for like safety incidents and number of pallets put on trucks per hour and things like that. And they just use that. They might be electronic by now. I mean, I did see them about 7 years ago, but it was only 7 years ago. It worked really well for them. And apparently they were one of the best examples of lean outside of Toyota. They were using paper and pencil, so I was quite.
That's also knowing your audience and knowing that there's such a variety of technology scope in their workforce. So understanding that everyone knows how to use a pen and paper and knows how to plot on a graph, that also comes down to that rather than people possibly having to log in and track and use technology that they're not educated in as well.
Yeah.
Good. That's a really good point. Interesting story. So, any other thoughts from anyone else? Any thoughts from our online team? Anyone want to add anything? Well, in that case, we'll wrap it up then, but I guess the goals from this is to go, as you go back into your jobs, think about opportunities where you could start to look at the data and maybe some of the tools that you could use to do that, and that would be a really good outcome from this. Thank you.
Thanks very much, Rachel.
Thank you.
Thank you.
Thank you, Rachel.
Thanks. See ya.
Bye.